So pre-multiplying this equation both sides by x transpose x whole inverse, we get, so x transpose x whole inverse times this left hand side and x transpose x whole inverse times this right hand side. So in order to simplify this further, we know this general rule that inverse of a matrix A times the matrix itself is the identity matrix. So here we can see that x transpose x whole inverse and then x transpose x. So the product of this will also become identity according to this rule. Inverse times the matrix itself is identity. So here x transpose x whole inverse times the same matrix without inverse. So their product is identity matrix. So writing this as identity matrix, multiply the identity matrix with this beta hat, we get beta hat, because identity times any matrix or any vector is the same matrix or same vector. So I times beta hat is beta hat. So thus beta hat equals x transpose x whole inverse x transpose y. We can also write it as beta hat OLS, because OLS method is used to get this expression for beta hat. By the way, you can verify that the second partial derivative of RSS with respect to beta hat is 2 times x transpose x, and this matrix x transpose x is positive definite. This is the condition required for residual sum of squares to be minimum at beta hat, which is x transpose x whole inverse x transpose y. I will try covering these concepts in a separate video. But for now, please note that if X has a full column rank, then this OLS solution is unique and it minimizes residual sum of square, and this completes the proof.